So right now, there are 3 countries that aim to put people on the moon. And of course, the Artemis campaign, Artemis 3, which has now been pushed out to 2027. That's the program to put Americans on the moon. Chinese plan to land Chinese astronauts on the moon by 2030. And India has a longer-term goal of landing people on the moon by 2040. But they're in the process now of planning their space station program, so they intend to put a space station on orbit and follow that up eventually with lunar exploration.
Hello, welcome to the Space Policy Show. I'm Colleen Stover with the Center for Space Policy and Strategy, part of the Aerospace Corporation. I'm here with Dr. Angie Bukley to talk about advancing science and exploration, but in the context of the business of space as well. This is part of our deep dive series that includes discussions about the space economy, the U.S. national strategy, as well as U.S. leadership in commercial space. And today we look at LEO and cislunar environments. What promises are there for space-to-space and space-to-Earth activities? Who are the players? What challenges exist? And what big questions remain? If you enjoy today's show and you want to learn more, you can go to csps.aerospace.org/SA2025. I'll start by asking Dr. Bukley to introduce herself. Thanks so much for being here, Angie.
Thanks, Colleen. It's really a pleasure to talk with you again. I'm Angie Bukley. I am a technical fellow and senior scholar in the Center for Space Policy and Strategy at the Aerospace Corporation. My background is more technical than policy, although for the last 4 or 5 years, I've been working in the policy realm and have really, really enjoyed it because it's opened my eyes to how much depth there is in the space enterprise and how many disciplines it actually covers. So it's been really exciting to have that experience.
Well, we've definitely enjoyed having you. So thanks for joining the team here at CSPS. So I wanted to start off, well, first of all, I guess we do kind of need to define our terms, right? So I said that we were going to talk about LEO and cislunar. If I wanted to ask, the first question of what kind of promised return to Earth and kind of exploration does cislunar hold? But start by defining the term for us.
Okay. Well, cislunar space is that region of space, and I'm going to use the definition that is most commonly used these days. It's that region of space beyond the geosynchronous or geostationary orbit regime. Okay, so everything outside of geo, out to just past the Lagrange point 2 of the moon, and it actually extends out about 550,000 kilometers. So it's a pretty big volume of space. But we also include the surface of the moon. So it's not just the volume of space external to geo and in the vicinity of the moon and past the moon, it's also the surface of the moon. And with regard to the potential...
Let me just ask, before you move into that, just for a quick reference, Lagrange point, that is a kind of point, if you will, located on the far side of the moon.
Right. There are 5 Lagrange points associated with any 2 bodies orbiting each other. Like there's Lagrange points between the sun and the Earth, but we're considering the Earth-Moon Lagrange points, and there are 5 of these points. And it's these regions of space where gravity kind of balances out. The gravitational pull of the Earth and the gravitational pull of the moon sort of balance each other out. So there's 5 regions in space where it's a lot easier to do station keeping because the gravitational forces are kind of balanced out.
Right.
And the points of highest interest for lunar exploration are the L2 points, which is on the far side of the moon, and then Lagrange points 4 and 5, which are kind of diagonal. It's hard to show without an illustration, but that's basically it.
Okay. So cislunar is this region from geo all the way out to the other side of the moon, even
other side of L2, out to about 550,000 kilometers altitude from the Earth. So it's a the volume of space is about 1,000 times bigger than the volume enclosed by GEO. And GEO, as a reminder, is only 36,000 kilometers altitude from Earth. So it's relatively small compared to the volume of space we're talking about, just this lunar.
And if people want to see a picture, they can go to CSPS website and check out some really good graphics. So what about the potential, though? What are we looking at here? What does Cislunar offer?
So there's been a sudden interest in cislunar space because in 2018, there was a publication in the National Academy of Sciences, a journal, that confirmed the presence of water ice in the southern polar regions of the moon. There are these permanently shaded regions down in the craters around the south pole of the moon. And of course, not being exposed to solar radiation, it gets really, really cold. And so there's been a lot of observations made. We haven't actually sent a rover in there to dig and see what we could find, but there's evidence that there is water ice in those regions of the moon. And that's important because if there is, substantive quantities of water ice, that means we can break it down. We can process it for drinking water, for agricultural water, for just, general purpose needs water. We could also break it down into oxygen and hydrogen. And oxygen, of course, could be used in environmental control and life support system. So we like to breathe oxygen. And the really cool thing about hydrogen is you can use it as rocket fuel. And so if there's the possibility of making rocket fuel on the moon and sending vehicles from the moon rather than, from the deep gravitational well of the Earth, then it's 1/6 the amount of effort to get something going from the moon than it is from the Earth. So, that opens up a lot of possibilities for exploring the solar system. So lots of potential, and it's not just the water ice. There's the helium-3 possibilities, the regolith itself, rare earth metals, things like that we could possibly exploit and use not only on the surface of the moon, but potentially, if we can find an economic way to get those things back to Earth, close a business case, could be useful on Earth here. So there's a lot of interest right now, and we haven't even touched on the science aspects or any of the other things. So there's just lots and lots of potential. And if a business case can be made, then that's when we'll see a lot of this really get opened up.
And what about the science? Did you want to just touch on that?
Oh, sure. There's a lot of things we can do. I mean, there's exploration, and the aspiration is to send people to Mars, and so the moon is a great place to learn how to operate off planet in a reduced gravity environment. To better understand the effects of radiation, because the radiation environment is significantly different than what our astronauts experience in low Earth orbit. So it's a great way to study that and understand the effects of radiation on both humans and hardware long term. As far as the science returns, there's possibility to learn a lot more about the evolution of our solar system, learn more about the origins of the moon and the Earth, and just learn more so that we can. It's interesting that we can do Earth science on the moon. And then one of the other really exciting possibilities is putting radio telescopes in the quiet zone of the moon. There's an area on the moon where it's shielded from all the radio interference from Earth. So it's a quiet place where we can do radio astronomy and learn a lot more about what's going on in that realm, more than we can learn from making observations on Earth because of all the interference. And then, of course, we'll get into the governance things later. Governance is going to be something we have to address. If we have multiple parties working on the moon, we've got to figure out how we're all going to play together. So we'll get into that later in the conversation, I'm sure.
Yeah. No, thank you. I appreciate that. It's all very exciting, right? So you kind of framed it through, basically through the money aspect and through the science aspect. And, Leo, low Earth orbit, is very similar. that it can be framed kind of through that thing. So in Leo, in that microgravity environment, it's very unique because of crystallization. Apparently, so I'm not a scientist. I will put up front to people. So Angie, you are a scientist. So,
Engineer.
Help me out if I say anything grossly wrong. But, crystallization in a microgravity environment, because there's not that gravity, there's less convection. And so the crystal, which basically makes up almost everything in our world, these crystals, they grow more perfectly. And what that's meant for medicine, for potential disease treatments, from cancer to growing retinas in Leo, and just in general life sciences, that microgravity research has been an amazing kind of game changer. And as well, because crystals make up almost everything in our world, things like semiconductors in microchips can be created or produced more perfectly. Microfibers can be produced more perfectly, which gives them more efficiency, longer life, etc. So, from medicine to manufacturing, that crystallization process in Leo has been amazing. In terms of other kind of potential money makers in Leo, there's also the idea of we've got a debris problem. How can we do debris cleanup? Are we going to have depots like fuel depots or supply depots that are in low Earth orbit? Are we going to have tugs and pull things around and change orbits and little backpacks kind of thing? There's also the idea of just this fundamental life science, and you've kind of hinted on it, already, in terms of understanding our world, understanding how humans can live and thrive on the moon, beyond Mars, etc. So the fundamental research that maybe is not profitable, but is still very necessary for humans to be able to move to the next level.
Colleen, if I may interject, don't forget that we have learned so much about how the human body works by studying our astronauts in a microgravity environment. The space station, the atmospheric pressure in the space station is set at sea level, so that the only variable that's different is the microgravity. A slightly higher radiation environment, but then now we can pretty much isolate what's happening. That's the cause of it would be microgravity. So that's another plus, and a lot of that has carried over into medical applications, or things like that.
Yes, absolutely, and understanding the kind of the closed loop systems that exist on the International Space Station right now. The water purification, higher yields for agricultural products and stuff like that. You kind of mentioned it too. I mean, I would love to get a few from you, but like the spin-off technologies, right, that have come from this kind of research that's happening on ISS. And, the robotics that they've developed for use on the station, and how that has moved into the same kind of technology for prosthetics here on Earth. Memory foam is one of my favorite ones. MRIs and the digital imaging that has come about from it, spacesuit technology being transferred into athletic wear here on Earth. Well, one of my favorite ones, actually, I wrote down a few of them, but one of my favorite ones was lunar collection devices that had been, the spin-off is dustbusters, so the little handheld vacuums. But do you have any that come to mind right now?
You did a pretty good list. So there are many. I think the thing that I think is, for me, is the highest payoff are the things that we've learned about the vestibular system, and translated that into treatments for stroke patients and people who have balance issues, as well as the water purification. Well, that has been really key in helping in areas where it's hard to find clean water to drink, and can process the water and have clean drinking.
Yeah,
those are kind of my two favorites.
And those are good examples. One helping like the individual on an individual level, and one helping in more at a societal
community
level.
Yeah.
So I wanted to also ask you, so we've talked about the Cislunar and things to bring back, and the LEO environment, how that's unique, that microgravity environment for, kind of in the context of science and money. But who are the players that we're talking about? When I was preparing for today, I thought about the players that are involved and the commonalities that exist. And I came up with the 3 C's, right? Cooperation, competition, and commercial. So I don't know if you want to frame it that way, but how would you talk about the players that are involved here in the Cislunar arena?
I think we can talk about several categories of players, and I like the way you divided it up. We can think about the commercial players, okay? And the commercial industry is excited because if we're going to move forward with developing research facilities on the surface of the moon, there's going to be infrastructure required. And that's going to have to come from somewhere. So the commercial entities that would help develop that infrastructure, like launch pads, like habitats, like transportation, like communication systems, lunar GPS, if you will, position navigation and timing systems. That's all got to be put in place if we're going to be able to really thrive on the moon as we envision it. So there's going to be a lot of infrastructure required. And that's on top of the potential resource harvesting that might happen, depending, on what we find as we go through this exploration phase. In terms of the main players right now, it's countries, and we can think about it as 5 countries who are playing the lead roles, and that's, of course, the United States and China and India, Japan, and Russia. So those are the 5 main players right now, but there are a lot of other countries that are engaged at various levels as well. Some with the Chinese through the International Lunar Research Station. They have agreements with 13 countries and more than 30 institutional partners. And the idea there is to develop a research station on the moon. It won't be permanently staffed and crewed, or whatever the right word is. It'll be run robotically with occasional staffing crews coming there to do work. So that's one aspect. We all know about the Artemis program or the Artemis campaigns. And one of the goals of the Artemis campaign is to develop a research station on the moon, an outpost, an Artemis outpost there that would be crewed and where we would do research. And right now, not to get confused with the 2, we have 2 things going on here. We have the Artemis Accords, wherein we've got 50 now. When we published the document, it was 46, anyway, now we're up to 50. It was 45, and now it's 50. And it seems to be growing every couple of weeks. We add a few more countries. But that is a political agreement. That agreement was drafted by the State Department, and countries are signing on to that. And it's really an agreement about how we'll operate in the lunar regime. Okay, it's based on the Outer Space Treaty, so peaceful uses. We can't claim sovereignty, things like that, but we have to have due regard for what's going on there and things like that. But it's a political document. The Artemis campaign, there are international participants, obviously Japan and Canada for sure, and the United Arab Emirates are participating. And that is more bilateral agreements between the country or ESA or the entity and NASA.
European Space Agency.
That's the program element. That's okay. We're going to go build this thing. We're going to do this mission. The Artemis Accord is more of an agreement, and it's a great way for developing spacefaring nations to get engaged and at least be part of the process. So there's that. So there's that kind of cooperation, but there is this underlying competition that I sense. I really hesitate to call it a space race because where are we racing to? Okay, we've been to the moon. I guess the competition now is more about establishing a permanent presence, or at least a presence where we can do some level of research on the moon surface itself or in orbit around the moon. for the purposes of commercial or science or whatever it is that we're trying to do. So right now, there are 3 countries that aim to put people on the moon. And of course, the Artemis campaign, Artemis 3, which has now been pushed out to 2027. That's the program to put Americans on the moon. Chinese plan to land Chinese astronauts on the moon by 2030. And India has a longer-term goal of landing people on the moon by 2040. But they're in the process now of planning their space station program, so they intend to put a space station on orbit and follow that up eventually with lunar exploration. So there's a lot of, and you got 3 main players there. Of course, when the International Lunar Research Station was initiated, Russia was a partner with China. But since the Russian war on Ukraine, their level of investment in space exploration, of course, has diminished because of other things. And Japan is really now playing a big role. And there are a number of other countries, and they're all identified in our document and what they're doing. So yeah, it's a very exciting time.
Yeah, it is. Sorry.
I was going to say that spills over to Leo too, because now as we're transitioning to looking more at what we can do with this lunar space, there's still stuff that we have to do in Leo, right?
Yeah. There's, so the, kind of looking at the 3 C's for the low Earth orbit environment, if I was thinking about cooperation first, there's, a whole history of cooperation. Cosmonauts have been in space since 1971 continuously, right? So we've been in Leo. There's been humans flying around up there for decades, for that many decades. In 1988, there was the Space Station Freedom, and that was an agreement between several national space agencies, the US, Canada, Europe, and Japan, to create the kind of first space station. The agreement was kind of reworked to add Russia. And in 1998, that's basically the birth of International Space Station. 2 years later, it was flying around up there. So that's kind of this whole long history of international cooperation goes back many, many decades. There's also opportunities for cooperation in Leo. That soft diplomacy, I think, is a very important piece. And in my research, I wrote quite extensively about that, because I do think there's that kind of diplomatic calculus of space and how it lends to not just the U.S. Pride and prestige, but also that of our partner nations. How many times have you seen the NASA logo when you've been on holiday somewhere overseas, or people get excited about space, a single country that has, one satellite up there. That's a big deal, right? So that kind of soft diplomacy, the knowledge sharing, where the US NASA kind of shares what they learned with the good of humanity. And I think that pulls a lot of weight in terms of US leadership in the world. Also, there's the idea of partnership for just fundamental science, that humanity piece, the partnership for maybe going to the lunar surface, the partnerships in science for going to Mars eventually, the partnerships across to commercial companies for medicinal purposes, as we talked about earlier. And then think about academia, think about new startup businesses, think about other new kind of space entrants, right? Leo is much cheaper to get to. Now, more about the science of the orbit, but I can tell you that it takes a lot less fuel to get to Leo if you're a high school class or at a university and you're launching something up there to do an experiment. If you're a new company that's trying to find something new, kind of new industry. So besides the cooperation piece, of course, you mentioned the competition piece. And if we go back to my 3 C's, one might, as you pointed out, might very easily try to replace competition with China. They both start with C. But there is more to it than that, as you pointed out. So, Russia has the Russian orbital station that they're planning, according to news outlets, planning on being on orbit in 2027. Of course, the Ukraine war may steal some of that thunder in terms of the funding, but I don't have insight into that at all. There's also the Indian space station, and that's being planned where the first module will be launched in 2028 as of now, and they think they're going to have it fully operational with up to 3 astronauts, space for 3 astronauts by 2035. I mean, it will be modular, so it will eventually, fit up to 6. And then, of course, there's Tiangong, China's Tiangong station, and that has been on orbit since 2022. They have a number of science and technology agreements where nations and educational institutions are going to them and having. I think the last thing I read in the news was over 100 experiments that are promised over the next couple of years. And those are the national players are, of course, Russia, but also France and Germany and European Space Agency, Italy. So if that was to happen in terms of competition, if ISS will be retired by 2030, like what we're hearing, and Tiangong was the only space station, on orbit, what would that mean in terms of U.S. leadership for things like soft diplomacy that I was talking about? What would that mean for the history of cooperation? What would that mean for something simple like intellectual property and the basic science and the U.S. leadership there for getting us to the moon and Mars? So, yeah, that competition piece is a big one anyway. And then I know I was going to talk about the commercial piece also. There are a lot of space stations that NASA is supporting right now, commercial space stations. Some of them are funded, some of them are unfunded, some of them are science, kind of technology sharing agreements. The research that I've done, I've made a very nice table in one of our research papers that kind of lays out the currently planned ones. So I'll read them. There's, Axiom Station, which is NASA funded. It's got a firm fixed price, a firm fixed contract, and they are planning on putting up their first module and actually hooking it to the ISS before ISS deorbits. That's part of their business plan. That's part of their technology plan. And then they unhook it. I know that's not the right word.
Undock it.
Thank you. They're planning on docking to ISS and then undocking, and then being a free flying, kind of flying around on its own. There's Orbital Reef. There's Starlab Space, which is a really interesting one that has lots of international cooperation from Mitsubishi to Canadian. There's also, VAST, Haven 1 by VAST. That's an unfunded project, but NASA is supporting it with technology and sharing agreements. So all of these, all the ones, I hesitate to not say, think Platform, Pathfinder by Sierra, Starship by SpaceX. So all of these, though, they are going to be smaller. They're planned to be smaller than ISS. They are going to be shared, right? Because they're commercial, government will become just another customer. NASA will become just another customer, is the idea. Anything to add to those? I know I'm missing something here.
No, I think you covered that quite well. We'll see what happens in 2030 when the space station is supposed to be decommissioned and then deorbited in 2031 and sent to, I think it's Point Nemo in the South Pacific. That's the point on the Earth that's the farthest from any land. That's where you can go in the ocean and be as far from land as you can possibly be on the planet. So that's where they tend to put a lot of this re-entering space hardware. So, yeah, we still have a long way to go before we can get to, and we've still got technological challenge. We got challenges across the board with regard to Cislunar. We're still working on landing systems. We're still working on spacesuits, pretty fundamental things like that, like habitats. What kind of habitats are we going to have? How are we going to navigate? How are we going to communicate? We don't currently, the United States or NASA doesn't currently have any assets in lunar orbit that we can use for communication, whereas the Chinese have a system already. They have a spacecraft at L2 and a couple of other spacecraft in highly elliptical orbits around the moon. They can use that for communicating with their Chong missions. And so we've got to do something about that. Just, fundamental things like I know they're whittling down the number of landing sites and trying to make their best guess as to, where will the lunar ice be. And it's so unfortunate that the Viper program, that was going to be a rover that was sent to the lunar South Pole area to kind of do some preliminary prospecting and try to identify areas that had the highest probability of yielding water ice. And that NASA has canceled that program. I know they're looking for commercial opportunities to get it up there, but the Chinese are proceeding with their Chang'e 7 mission, which will do what Viper was supposed to do. So that's going to go up, I think, in late 25, early 26. I can't remember. Looked at so many dates lately. We're all mushes together.
Understood.
But, that's something that, those are challenges that we have to overcome. Lots of technical challenges, and just like in Leo, there's how do you close the business case? Can private companies go to the moon and make money? We don't know. It just depends on what sort of infrastructure we're going to do, how we're going to pursue that. If we find that unobtainium that somebody's going to make billions and billions of dollars on, are we going to be able to close a business case around it? But I think just like you've written in terms of Leo and getting the commercial space stations off the ground, there will be some reliance on the government. And the anchor tenancy thing is really important. And I think you know more about that, or you've looked more into that because of the nature of these low Earth orbit destinations.
Yeah, that anchor tenancy piece is, personally, I think it's still necessary. And I'll go out on that. But there is, I'm thinking of a shopping center, right? If you have a big anchor tenant in the shopping center, the idea is that it attracts more business, right? Now, it also usually gets a discount for signing a, 50-year lease. But, if investors can feel confident that the government is going to be participating in something, and that's a kind of consistent, reliable source of income for startups or not startups, I suppose, but just business, then it will attract more investment. That's the idea, right? Yeah. But they have to prove things. They have to have some skin in the game, right? Private capital has to have some skin in the game. You've got to prove that you're not completely dependent on government over a long term. There's got to be something, reliable about your business plan, and you have to demonstrate that you're going to have more customers than just government.
Absolutely. And I think the whole idea is for the government to phase out Leo and let the commercial entities develop Leo. Of course, they'll continue to do science, but more as hopefully one of many customers. But yeah, and of course the anchor tenancy, we have to think about all the constraints in Title 51 and all of that, so that we don't get crossways of like the law. But yeah, lots of potential there. I think the other major challenge, particularly in cislunar space, is going to be the governance model, because the Outer Space Treaty says you can't claim sovereignty on another planetary body or to any region in space, but it doesn't talk about coexistence of two different entities with perhaps different purposes. So there's the due regard part where you have to respect, if India, for example, lands on the South Pole of the Moon and sets up some kind of little research establishment there, then that needs to be respected. You don't want, the U.S. or China to come try to land right on top of where they are.
Or even close by. They kick up all the dust, right?
Yeah. Well, the dust thing, there's going to have to be landing pads put in. So there's infrastructure needed from the get-go. To avoid all that dust flying around. But you're right. At first, yeah, you just don't want to go blasting them, and so that's going to mean some distance between them, and that's important to think about too with respect to some of the heritage sites. I mean, we have the Apollo sites, and especially the Apollo 11 site should be preserved. And that's my humble opinion, and so hopefully the due regard will be paid for as other entities land in those regions to preserve that. But yeah, the United States really needs to remain engaged. I think it's important that we engage with China to just better understand what they're doing, engage with India. I don't know that it would ever lead to cooperation. There are many political hurdles that would have to be overcome to get to a point of cooperation, but perhaps some kind of healthy co-opetition, as we've written in the papers, that, competition is good. I mean, I think competition is great. It really, I'm a very competitive person, and if I think someone's catching up, I'm going to do my best to try to stay out in front. But I think it's crucial that the United States stay engaged and be part of the conversation as we develop these norms of behavior. I would be interested to see, I mean, I know what the Artemis Accords have, and I understand in the International Lunar Research Station, there's a document similar, but we have no access to it, so we don't know what it says, and apparently it's also based on the Outer Space Treaty. But I haven't seen it. I don't know anyone who has, so you can only speculate, but it would be interesting there. But yeah, still a lot of work to do, a lot of challenges to overcome, but I think the governance piece is going to be really vital, that the U.S. play a big role in getting that developed. And that's going to carry over to low Earth orbit research as well. But on the moon, it would be hard to imagine that humans will go anywhere and not bring the problems that we have on Earth with us to whether we go to the moon or go to Mars. So we're going to really have to come up with what the governance structure is going to be like. And it's going to evolve. So
it's going to evolve, yeah.
It will probably be different than anything we might imagine.
Yes. We might be able to watch some good science fiction in order to get some insight into what that might look like.
Absolutely.
In terms of governance, though, you mentioned it for the low Earth orbit, for the commercial stations. I'm thinking about these kind of shared users and shared usages on single stations, right? Mm-hmm. I mean, are they going to be tourists or are they going to be national astronauts? You're talking about industry, maybe some manufacturing and some science, doing some testing and research. What are this kind of shared infrastructure? What if you have a space participant, a tourist, kind of float by and kick somebody's science experiment over, and now their science experiment, millions of dollars wasted, right? What kind of liabilities are there? How are they what's the data protection, the data privacy conduits there? What about export control? I mean, these are commercial stations. They're not national. How are you going to control, intellectual property? Just, even code of conduct among people that are there. So that governance piece on each of the commercial stations, if there's not a one size fits all, then they're going to have to come up with something that considers all of those things. So
yeah, and with regard to potential spaceflight participants or space tourists, whatever we settle on calling them, maybe the thing to do is have the hotel module totally separate from the science module. Maybe let them have a tour of the science module, but spend most of the time. I mean, interference with experiments. It's well known that the astronauts are a huge source of noise when you're trying to do sensitive measurements, because they move around and they run into things. So yeah, it's definitely something that has to be considered.
But for me, my concern technically is the interoperability, right? Are we going to have a beta VHS war here, right? Is it going to be a 3-prong plug or a 2-prong plug?
Or a 4-prong plug?
No. Yeah. So for me, it's interoperability in terms of how all of these ideas can come to fruition, but we can all also build off of each other, some sort of shared standardization, infrastructure, ground support, launch, something where we can all thrive together. So,
and that's going to be really critical, not if, but when space rescue is required. Because
right.
if you've got a vehicle in proximity to another vehicle that's having issues and their docking ports aren't compatible, well, there you go. So for the long term, yeah, something like the USB standards, but for space.
Absolutely. So some final thoughts here as we go. I think we're both agreeing that U.S. presence, we would like to continue U.S. presence in both LEO and the Cislunar, U.S. leadership. I think that we're also kind of agreeing that we're going to need that kind of continued government support, whether it's, seeding innovation, whether it's creating infrastructure, whether it's being one of many, many customers, but then the idea of what flavor of support is that, right? What flavor of partnership is that between the public and the private?
Absolutely.
We talked a little bit about ISS retirement. There is, there's swirl around the way it's being retired because it's being deorbited, and possible other use cases for it, whether it's, let's keep it up there and recycle that, 460 tons of metal, right? Let's keep it up there and practice servicing and manufacturing techniques. Let's keep it up there for tourism. Maybe, a few decades from now, we can have tourists go visit it in a graveyard type orbit. But, all of that takes a lot of governance, policy changes. It's not owned by just the U.S. There's multiple owners to ISS. And yeah, so that kind of remains to be seen, I would say. But also, too, I think we both agreed on what that killer app might be for both LEO and Cislunar, right? The killer app, what's going to change everything? Is it going to be a very efficient way of mining helium-3 from the moon and being able to economically bring it back to Earth and generate, power? Is it going to be some sort of biotech, big pharma discovery in the microgravity environment that we can then, sell for millions? So yeah, what kind of closing thoughts do you have that you want to leave our audience with?
Well, I think these are very exciting times. I know that, in terms of looking at potential resources that we can harvest from the moon, there are already people talking about ways to efficiently fling those back to Earth using some kind of magnetic rail launchers or the spin launcher or something like that, because you just got to push it in the right direction and then guide it in when you get close. But I mean, who knows? I mean, there's so much yet to be figured out. I'm really excited to see how these things pan out. Not sure I'll be around when we get to Mars, but maybe. It's like I said, it's a very exciting time. At times, I wish I was just starting my career rather than coming to the point where I'm about to wrap it up. But yeah, it's I can't wait to see what happens, and I will follow it dutifully. So.
Wonderful. Well, thank you, Angie, for appearing on the show. And I really enjoyed working with you on the projects that we've been working on. And I know you're never going to leave the space world completely. You'll always be
ever. No.
So to our audience, remember, you can read more about these issues, kind of advancing science and exploration at csps.aerospace.org/essay2025. Here is the essay, the Space Agenda 2025 volume, all beautifully bound, where we've got 15 different chapters that are covering some of the biggest space issues to unfold in the next few years. So if you want to learn more. You'll also find 2 research papers by Dr. Bukley and I, Moonstruck, International Aspirations in Cislunar Space, and Mind the Gap, Commercial Space Stations and the ISS. All of our shows are available on YouTube or wherever you get podcasts. Follow us on LinkedIn for notifications and engagement. And shout out to James Liggins, our technical director. Thank you to our audience for watching or listening.